Question 1. Find all excluded values for the expression. That is, find all values of w for which the expression is undefined. Remember, in dealing with fractions, if your denominator is 0, then the expression is undefined. So what we're going to do here is look at our denominator, 4w plus 12, and say 4w plus 12 cannot equal 0. And then we're going to solve the equation for w. So we're going to subtract 12 from both sides in order to isolate. And then divide by 4. So w cannot equal -3, because if w equaled -3, it would make our denominator 0 and our expression undefined. So -3 would be our excluded value. Let's do another one. Question 2. Find all excluded values for the expression x squared minus 5x minus 24 over x squared plus 9x minus 10. Again, for this expression to be undefined, our denominator cannot equal 0. So we don't pay attention to the numerator. And we say that x squared plus 9x minus 10 cannot equal 0. Now, since we have an x squared, we have to factor. And so in this case, we can use our shortcut in factoring. And remember, we're looking for the factors of -10 that add to a +9. So that would be a +10 and a -1, because +10 minus 1 is +9, and 10 times -1 is -10. Now, we set each factor individually and state that it cannot equal 0, and then solve. So we know that x cannot equal -10, so that's one of our excluded values. And in the second one, when we're solving for x cannot equal +1. So our two values, -10 and 1, if replaced in for x, would make our denominator 0 or undefined. So those two values, -10 and 1, would be our excluded values. Let's look at simplifying rational expressions. So what we're doing here is really reducing fractions. So here we have 40w x to the fourth over 28w squared x to the fourth. So what I'm going to do is rewrite this and make sure everything has an exponent. So the w is really w to the first. And in our denominator, we have 28w squared x to the fourth. So we're going to reduce. So we're going to start by looking at our coefficients 40 and 28 and dividing out the greatest common factor. So the greatest common factor of 40 and 28 is 4. So we're dividing each one of these by 4. So 40 divided by 4 is 10, and 28 divided by 4 is 7. Now, with our variable, we're going to subtract. And so it's best if we look to see where we have more of that particular variable. So we have more w's in the denominator than we do in the numerator. So w will be in our denominator in our final answer. How many we have, we get by subtracting 2 minus the number we had in the numerator. So 2 minus 1 is 1. Now with our x's, those reduce to 1 because anything over itself is 1. So in the numerator, we have 10 times 1, which is 10. And in the denominator, 7 times w times 1 is simply 7w. The next one, 6v to the fourth w to the fifth over 18vw. So again, I'm going to rewrite it, making sure everything has an exponent. And reduce each factor individually. So the greatest common factor of 6 and 18 is 6. So I'm going to divide a 6 out of each one, giving me 1 over 3. And remember, with our variables, wherever we have the most is where it's going to be in our final answer. So we'll have v up top, and we subtract 4 minus 1, which would give us 3. And for our w again, we have more w's in the numerator. We have 5 in the numerator, 1 in the denominator, so we're going to subtract. And remember, we have more in the numerator, so that's where it's going to be in our final answer. So in our numerator, we have 1 times v to the third times w to the fourth, which is v to the third, w to the fourth, over 3. Question 5, we're simplifying a fraction again. And in the numerator, we have 5 times the quantity 2u plus 3 times the quantity u plus 2. And in the denominator, we have 40 times the quantity u minus 8 times the quantity 2u plus 3. So again, we're going to reduce common factors. So when we look at our coefficients 5 and 40, 5 goes into both, so we divide 5 out of the 5, giving us 1. And 5 goes into 40 8 times. Now we're going to look for other common factors. And we see both the numerator and denominator have 2u plus 3. And remember, anything over itself reduces to 1. Now nothing else reduces, so we multiply 1 times u plus 2, which is u plus 2. And in the denominator, we multiply 8 times u minus 8 times 1. And we don't really need to distribute the 8 times these, so we would leave our answer as the quantity u plus 2 over 8 times u minus 8. Okay, let's look at another one. Now in some cases, like question 6, we're going to have to factor. So in the numerator, we have 5x squared minus 20x, and in the denominator, 3x squared minus 12x. So remember that the first step in factoring is to remove the greatest common factor. So what I usually do is put them in parentheses, reminding myself that they represent a single factor. I can't reduce these individually because I have a minus sign separating them. And in the numerator, I compare 5 and 20, and the greatest common factor would be 5. They both have x's, and remember, you take out the one with the smallest exponent, which would be x to the first. So when I divide 5x out of each one of these two, I get x minus 4. So in the numerator, I have 5x times the quantity x minus 4. In the denominator, the same thing. So the greatest common factor of 3 and 12 is 3. They both have an x, so I can factor out an x. And the one with the smallest exponent is 1, so all I can factor out is x to the first. And then when I divide that out of each term, I end up with x minus 4. So in the numerator, 5x times the quantity x minus 4, and in the denominator 3x times the quantity x minus 4. Now you reduce. So the x minus 4's reduce, and remember again, anything over itself is 1. And the x's can also reduce because there's not a plus or minus sign separating the factors. So those also reduce to 1. So in the numerator I have 5 times 1 times 1, which is 5. And in the denominator 3 times 1 times 1, which is 3. So question 7, it's two separate problems, and it's asking us to simplify if possible. The first one is 2w plus 5 over 5w plus 2. Remember, it's a good idea to put these in parentheses to remind yourself that together they represent a single factor. So they're not the same, and I can't factor anything out of either one. So this is simplified as much as it can possibly be simplified. So our answer would be 2w plus 5 over 5w plus 2. Now the second one, we have w plus 4 over the opposite of w minus 4. So again, I put these in parentheses and I factor if possible. So the numerator cannot be factored, so that remains w plus 4. And in my denominator, I can factor out a negative 1, or just a negative. So when I factor out a negative 1, what it does is changes both of these signs. So negative w becomes w, and negative 4 becomes positive 4. Now I reduce. Remember, anything over itself is 1. So what I have in the numerator is 1, and what I have in the denominator is negative 1. So remember, a positive over a negative is a negative, and 1 over 1 is 1. So my answer would be negative 1. Okay, let's look at simplifying another one. Here I have u minus 7, and again, I'm putting it in parentheses. And in my denominator, I have u squared minus 6u minus 7. And again, I put it in parentheses. Now we're going to factor if possible. We know that the numerator cannot be factored. But in the denominator, we can factor using our shortcut in factoring, since this is just a u squared and it doesn't have a coefficient greater than 1. So I look for the factors of negative 7 that add to a negative 6, which would be a negative 7 and a positive 1. Because negative 7 plus 1 is negative 6, which is our middle term, and negative 7 times positive 1 is negative 7. Now we reduce. We see that both have the factor of u minus 7, and this is why it's important that when we reduce, we're not canceling, we reduce, anything over itself is 1. So our numerator has a factor of 1. And in our denominator, we multiply 1 times u plus 1, which is u plus 1. So our final answer is 1 over u plus 1. Our next problem, again we have a fraction that we're going to simplify, or a rational expression. So remember, it's best to put it in parentheses to remind yourself they belong together as a single factor, and that factoring may be necessary. So when we look at the numerator, this is the difference of two squares. 9u squared is a perfect square, as is 49, and it's separated by a minus sign. So we're going to go ahead and use that special factoring technique. 3u times 3u gives us the 9u squared. 7 times 7 gives us 49. And remember, to get a negative 49, one has to be positive and the other one has to be negative. Now we need to factor our denominator. Now, since our leading coefficient is greater than 1, we're going to have to use the AC method or reverse FOIL method in order to factor. So, just as a reminder, we take our leading coefficient, multiplying it times our constant in this case. So 3 times negative 35 is negative 105. Now we're going to look for the factors of negative 105 that add to a positive 8. And that's going to be positive 15 and negative 7. So what we do is we rewrite our middle term using those two factors in any order. And then remember, we group the first two together and the last two together and remove the greatest common factor. So in the first group, the greatest common factor is 3u. And when we divide 3u out of both of those terms, that gives us u plus 5. Now in the second grouping, since this is a negative, we're going to factor out a negative, and 7 goes into both 7 and 35. So we're dividing negative 7 out of each, and that will also leave us with u plus 5. Now our greatest common factor is u plus 5. And when we divide it out of each of the terms, that will leave us with 3u minus 7. So our denominator is going to be, and it doesn't make a difference the order, u plus 5 times 3u minus 7. So now we look for common factors to reduce, and we see that they both have 3u minus 7. And again, remember, anything over itself is 1. It doesn't cancel or disappear. It reduces to 1. And now, since nothing else reduces, we multiply what we have left. So in the numerator, we have 3u plus 7 times 1, which is 3u plus 7. And in the denominator, we have u plus 5 times 1, which is u plus 5. It doesn't make a difference whether or not you have them in parentheses, but I'll go ahead and put them in parentheses. Okay, now in multiplying fractions, and then the directions say simplify your answers as much as possible. So it's going to be primarily the same technique. So what we have is 6 b to the first c to the first over 12 c to the first times 3, and again I put in the exponent, c to the first over 2 b to the first. Now with multiplication, you can think of this as just one fraction. So anything in the numerator can reduce with anything in the denominator. So we can start with the coefficients, 6 and 12, and the greatest common factor is 6. So I'm going to divide 6 out of each one, and that gives me 1 in the numerator and 2 in the denominator. Now we see also that c to the first is in both the numerator and denominator, and again, anything over itself reduces to 1. And we also have b to the first in the numerator and denominator, which again reduce to 1. Now, nothing else reduces, so we go ahead and multiply straight across. So 1 times 1 times 1 times 3 times c to the first is 3c to the first, or just 3c. And in our denominator, we have 2 times 1 times 2 times 1, which is 4. So our final answer would be 3c over 4. So again, same technique as we just used in the other problems. Let's look at another multiplication problem. So in this case, I'm going to go back to the technique of making sure I put these in parentheses. And again, that reminds me that they belong together as a single factor. And also that factoring may be necessary in this problem. And again, remember, since it's multiplication, I can think of this as a single fraction. So 9x minus 8 cannot factor any further. Nor can x minus 6 in the numerator. Now in the denominator, 3x minus 18, I can factor out a 3 since that's the greatest common factor. And when I divide that out of each term, that leaves me 3 times the quantity x minus 6. Now for 2x plus 16, again, I can take out the greatest common factor, which is 2. And when I divide 2 out of each, that leaves me with x plus 8. Okay, so now we look for common factors. So both numerator and denominator have x minus 6. So again, those reduce to 1. And nothing else reduces. So in my numerator, I'm left with 9x minus 8. And in my denominator, 3 times 1 times 2 is 6. And I still have the quantity x plus 8. So you don't need to distribute. You can leave your answer as 9x minus 8 over 6 times the quantity x plus 8. Let's look at another multiplication problem. I'm going to go ahead and put these in parentheses again to remind myself they may need to be factored and that they belong together and can't be reduced individually. Now again, since it's multiplication, I can think of it as just being one large fraction. So I have x squared minus 4x plus 3 in the numerator along with x plus 3. And in my denominator, I have 4x plus 12 and x squared minus 2x minus 3. So I'm going to look at the x squared minus 4x plus 3. And remember, we can use the shortcut since our leading coefficient is 1. So I'm looking for the factors of positive 3 that add to a negative 4. And that would be a negative 3 and a negative 1, since negative 3 times negative 1 is positive 3, and negative 3 plus negative 1 is negative 4. Now still looking at my numerator, x plus 3 just remains x plus 3 because there's no factor that I can take out. In the denominator, looking at 4x plus 12, the greatest common factor is 4, so I factor out a 4, and that leaves me 4 times the quantity x plus 3. Now the other factor, x squared minus 2x minus 3, again, we can use that shortcut since our leading coefficient is 1. So again, we're looking for the factor of negative 3 that add to negative 2. And that would be a negative 3 and a positive 1. Since negative 3 plus 1 gives me negative 2, and negative 3 times positive 1 gives me negative 3. So now we look for common factors. So we can start with the x plus 3, which is found in both the numerator and denominator, reduced to 1. The x minus 3 found in the numerator and denominator, and again reduces to 1. Now x minus 1 and x plus 1 cannot reduce. They're not the same, nor are they completely opposite. So what we have left in the numerator is x minus 1, and in the denominator we have 4 times 1, which is 4, times the quantity x plus 1. One more multiplication problem. So again, I'm going to put everything in parentheses and factor whenever possible. So in the numerator, I have 14x squared plus x minus 3 times x minus 2. So again, I think of this as one large fraction. And in my denominator, I have 4x minus 8 times 49x squared minus 9. So I'm going to start with the numerator and look at 14x squared plus x minus 3. The greatest common factor is 1, so I have to go to my AC method or reverse FOIL method since my leading coefficient is 14. So I multiply 14 times negative 3, and that gives me negative 42. So I'm looking for the factors of negative 42 that add to my middle term, which is a positive 1. So that would be a positive 7 and a negative 6. So I rewrite my expression so it becomes 14x squared plus 7x minus 6x minus 3, and then we factor by grouping. So in the first group, 7x is the greatest common factor. So when I factor out a 7x, that leaves me a 2x plus 1. And in my second grouping, remember, since this is a negative, I'm going to factor out a negative. And the greatest common factor of 6 and 3 is 3. So I'm dividing negative 3 out of each one, and that gives me 2x plus 1 as well. My last step, my greatest common factor is that 2x plus 1. And when I factor out 2x plus 1 from each, that would leave me 7x minus 3. So in my numerator right now, I have 2x plus 1 times 7x minus 3 times the x minus 2, because nothing can be done with the x minus 2. Now, looking at the denominator, I look at the 4x minus 8. I can factor out a 4, and when I do that, that leaves me 4 times the quantity x minus 2. Now my second factor is 49x squared minus 9. Again, we're dealing with special factoring, the difference of two squares. So that's going to factor to 7x times 7x, 3 times 3, and remember, one's a plus and one's a minus in order to get our negative 9. And now we'll reduce by looking for common factors. So I see that both numerator and denominator have x minus 2. They also have 7x minus 3. And that's all they have in common. So in my numerator, I have 2x plus 1. And in my denominator, I have 4. And the factor 7x plus 3. So my final answer would be 2x plus 1 over 4 times 7x plus 3. And now let's look at division. Remember that division is primarily the same as multiplication. The only difference is, remember, we change whenever we're dividing fractions. We change division to multiplication, and we take the reciprocal of the divisor. So I'm going to start by doing that. I have x plus 4 in the numerator, and in my denominator, 4x minus 28. Now remember, when I'm taking the reciprocal, the 8x minus 56 now goes into the numerator, and the 9x plus 36 goes in the denominator. So now we're going to factor. The x plus 4 cannot factor, so it remains the same. And the 8x minus 56, the greatest common factor is 8. And so when I divide an 8 out, that leaves me 8 times the quantity x minus 7. Now in my denominator, I have 4x minus 28. The greatest common factor is 4. So when I divide 4 out, that gives me 4 times the quantity x minus 7. And then 9x plus 36 has a greatest common factor of 9. So when I divide 9 out of 9x plus 36, that leaves me 9 times the quantity x plus 4. So now we reduce. So both numerator and denominator have factors of x minus 7, have common factors of x plus 4. And now I look at my coefficients, and 4 goes into 4 one time and into 8 two times, and nothing else reduces. So in my numerator I have 1 times 2 times 1, which is 2. And in my denominator I have 1 times 1 times 9 times 1, which is 9. So my answer would be 2/9.